In this video, we will learn how to determine the existence of a limit of a function. So, to test the existence of a limit, we have to use our previous concept called one-sided limit. If we check the limit from the left side and from the right side and we get the same value, we call the limit exists and we accept that is the limit. A limit exists if and only if both one-sided limit exists are equal. For example, if we have limit of x approaches 2 from left and limit of x approaches 2 from right is 3, then we can conclude that limit of x approaches 2 of fx is 3. But if we have limit of x approaches 2 from left is 3 and limit of x approaches 2 from right is 2, we can conclude that limit of x approaches 2 of our fx basically does not exist. We will do example 7 to check our understanding. Given that hx is basically a piecewise function, we have 4 minus x squared when x is less or equal to 1 and 2 plus x squared when x is greater than 1. Now we have to find limit as x approaches 1 from left, 1 from right, and limit as x approaches 1. I advise to all of you to draw the number line first to avoid any confusion. So now our number line, the limit value would be 1. So when our x is less or equal to 1, our function would be 4 minus x squared. And when it is greater than 1, our function would be 2 plus x squared. From here, we can directly answer the question. So for the first one, we have to find limit x approaches 1 from left of hx. So we have to detect what is the function of x approaches 1 from left. In this case, our function is 4 minus x squared. Be careful here, you must choose the correct function. I repeat, you must choose the correct function. So after that, directly substitute as usual to find our limit. So substitute 1 into our limit function. We're gonna get 3 as our final answer. Next one, we have to find limit of x approaches 1 from right of hx. In this case, for limit of x approaches 1 from right, the function would be 2 plus x squared. Now, directly substitute the limit value into our function, so we're gonna get 2 plus 1 squared. So our final answer is also 3. Since we get the same value for both answers, we can conclude that limit of x approaches 1 of hx is equal to 3. We practice once again for example 8. Given the function of fx is once again a piecewise function, so our function would be 2x when x is less or equal to 4 and 2x plus 3 when x is greater than 4. Once again, at first, try to draw our number line, which in this case 4 would be the limit value. We will draw when x is less or equal to 4, the function would be 2x. And when x is greater than 4, the function would be 2x plus 3. So here would be 4 from left, and at the front will be 4 from right. Now we can answer the question. So first, for limit of x approaches 4 from left, we will have 2x as our function. Once again, directly substitute the limit value into the limit function, and we're gonna get 8 as our final answer. Second one, for limit as x approaches 4 from right, our function would be 2x plus 3. Now, in order to find the answer, once again, just directly substitute the limit value into the limit function, and our final answer in this case would be 11. So, from the left side and from the right side, we basically get a different answer. As a conclusion, our final answer for limit of x approaches 4 of fx would be does not exist. Proceed to the next example, last one. Example 9. If we have, once again, a piecewise function, 2 when x is greater than 1, 0 when x is equal to 1, and negative 2 when x is less than 1. Determine the following limit. As usual, first step, draw your number line. So we will have negative 2 when x is less than 1, and we have 2 when x is greater than 1, and 0 when x is exactly at 1. Now we can answer the question. First one, limit of x approaches 1 from left. So 1 from the back, we know the function is negative 2. So our final answer would be negative 2. Next one, for limit x approaches 1 from right. So from the number line, we have to check the function at the front. In this case, would be 2. So our final answer would be 2. From here, we can detect that limit of x approaches 1 from left does not equal to limit of x approaches 1 from right. So we can conclude that limit as x approaches 1 of fx does not exist.